Yeah, here at 59. Okay. Okay. So in this triangle, you drew an altitude, and we could say that the sine of A is K over C and the sine of C is K over A. Both of these equations involve K, which means we could solve for K and set K equal to K, right? So then if we divide the little c over to be with sine of C, and we divide little a over to be with sine of A, we have something that looks like this. When you got to here, does this look familiar? Only a few heads are sort of nodding. Okay, fine if it doesn't. But you've totally seen this before, okay? Actually, you might not have. You did? Okay, well, there's some things that like had to be taught differently last year because of the shutdown in 2020, but I think algebra 2 is pretty safe. Okay, we're okay. We're okay. All right. So then we went to the same triangle, but we drew a different altitude. We drew it from vertex C. And I don't know why they called it K. I don't really love that they called it K again, but whatever. Okay. So the sine of A is K over B. And the sine of B is K over A. So we can do the same thing where these both have a K, which means we could solve for a K. Hold on. We can set our K's equal to each other. And we can move the A over to be with sine of A and the B over to be with sine of B. And hey, on the first page, didn't we have like the sine of A over A equals the sine of C over C? So by the transitive property, we have the sine of A over A equals the sine of B over B equals the sine of C over C. And this is what we call the law of sines. Okay. Eric's question, what does this do for us? Okay. Let's come up to our triangle. Capital A, B, and C. What do they represent? They represent angles. Little a, B, C. What do they represent? Sides. So what we're going to be able to do is we're going to be able to use the law of sines to solve for sides and angles in an oblique triangle. Okay. We did a lot of work in chapter 4 with solving for sides and angles in right triangles. Like we're professionals at that. Okay. But what if a triangle does not have a right angle? Well, we, as mathematicians, just figured out a formula that we can use to solve for sides and angles when we have an oblique triangle. Now, the sad news is we can only use the law of sines in 3 particular cases. Okay, so this is when we're going to transition to your notes here, people. Okay, first of all, here's the law of sines. So I would suggest writing it down in your notebook. Okay, so you have that to reference. Okay, we're using this to help us solve for sides and angles in oblique triangles, but the law of sines can only be used when we have 2 angles in a side or 2 sides and an excluded angle. What is it? Yeah, there's a reason why I organized that third one the way that I did. So you had proofs for similar triangles that involved these. But this is, so this has nothing to do with similar triangles, thank God, right? This just has to do with these would be the sets of given information where these formulas are actually going to be helpful for us, okay? So if we know two angles and one side, we can use a proportion from this formula to help us solve for the rest, okay? Now, if we have two sides and an angle not in between, we can use law of sines. If the angle is in between the two sides, like side, angle, side, we have to use the law of cosines, which we'll learn on Friday. Now, you notice that that third one is arranged a particular way on purpose, right? Like it sticks out a little bit. No, you don't see it? Okay. Okay. We're going to talk about that case tomorrow because that's a special case. All right. When we have side angle, we have something that happens called the ambiguous case. And we have a little bit more work that we need to do, and we have some things that we need to talk about. So today we're going to focus on these two right here, and then tomorrow we'll talk about the ambiguous case. All right. Now let's come back up to our formula. Are you going to use all three pieces simultaneously? No. You are going to pick two ratios and make a proportion based on what's going to be helpful for you to solve. So maybe you're going to pick the sine of A over A equals the sine of B over B, and you're going to do some solving. Or maybe you're going to pick the sine of A over A equals the sine of C over C, and you're going to do some solving. Or the B's and the C's. You just pick the two ratios to set equal to each other. That's going to help you. Okay. And it's going to be obvious because you're going to have to know a side and its opposite angle. Okay. And then as long as you know one of the other pieces, we can solve for that fourth. Now, I want you to keep in mind that when we have oblique triangles, angle A is opposite of side A. Angle B is opposite of side B. And angle C is opposite of side C. Okay. What else do we know? What's true about the biggest angle? It's across from the biggest side. The smallest angle is across from the smallest side. Okay, so we need to keep those things in mind as we get our answers to make sure that our answers make sense. I need you to get your calculators out. Okay, and sometimes we got to go back to degree mode. So get out your calculators and make sure that you are in degree mode. Okay, every time you do a problem, guess what I'm going to have you do? You need to draw a picture. Okay, you need to draw a picture so you can visualize what's happening, so you can determine which formula to use. Now, I know that right now we only know the law of sines, but Friday we'll know the law of cosines, and we'll really have to keep straight when to use which formula. Okay, so we know that angle A is 32 degrees. We know that angle B is 50 degrees, and that we know side C is 18.7 centimeters. Okay, do you notice how we know two angles and a side that is in between the two angles? Okay, because we know angle, side, angle, we can use the law of sines. Okay, now notice how we don't know like a pair of information. What would be the easiest thing to find first? The other angle. What's true about our three angles? Okay, so angle C, we're going to take 180 and subtract out 50 and 32, which means angle C is what? 98 degrees. So you guys may have heard of like NSYNC and Backstreet Boys, right? Back when I was growing up, boy bands were a big deal. There was actually a band called 98 Degrees. You don't know them because they weren't really that popular, but well, they were popular, but not popular enough to be remembered. No. Fun fact. Fun fact. What? I don't know. It was Nick Lachey. Yeah. See? Don't even know. That's how old I am. I'm getting there. Yes. Yes, I am. Thank you for thinking that. I graduated high school when a lot of you were born. 2004 is when I graduated. Sometimes I feel. Okay, so now that we know angle C, do you notice how we can pair it up with side C? So we know that the sine of 98 degrees over 18.7 is going to equal, let's pick A first, alphabetical order, the sine of 32 degrees over side A. Okay, now here's the deal. Don't start typing things into your calculator quite yet. Can you guys like look at me and listen to what I'm saying? Okay, you have a really nice calculator. And in no way do I want you to round and write something down and then keep doing math. This is what I want you to do so that you can get the most accurate answer possible. How do we solve a proportion? We need to cross multiply. So we have A times the sine of 98 degrees equals 18.7 times the sine of 32 degrees. You are not going to put that in your calculator and write it down. Write it like this. Now we know that in our calculator, we need to take 18.7 times the sine of 32 degrees and then divide over the sine of 98 degrees. So in degree mode, I am going to take, what did I say? 18.7 times the sine of 32 degrees. Notice how when you type in sine, it opens a parentheses. Please close the parentheses before dividing by the sine of 98. And we're going to go ahead and get in the habit of rounding to the nearest hundredth. So what are we going to call this? .01. And since I started out with a side length labeled in centimeters, we'll go ahead and label this in centimeters also. Put on charger. Silly. That was silly. Now we're going to be doing enough of these to where eventually you're probably not even going to show this step. Okay. And that's fine. I at least need the setup and your answer. Bare minimum, set up and answer. Okay. All right. Now we need to solve a second proportion so that we can figure out side B. Now remember, this is an oblique triangle. Pythagorean theorem is out the window. Don't use it. Okay. Now, when I set up my proportion for the sine of angle B, 50 degrees over side B, which pair of angle side should I pick? A's or C's? Technically, it doesn't matter, but one's going to be more accurate. Okay, if we can use given information, we need to. All right. Sometimes it's unavoidable that we have to use a rounded answer, but the more given information you can use, the more accurate your answers are going to be. Okay. So here, when we cross multiply, we have 18.7 times the sine of 50 degrees equals B times the sine of 98 degrees. And if we divide 98 degrees over, $14.47. That sound good? Doesn't feel good to use your calculator again. Okay. I just told you what the hardest unit was. Yeah. Of the entire year, chapter 5 was the most difficult. Okay. Now, let's talk about my expectations. Because right now this isn't so bad, right? Okay. On the quiz Tuesday, every triangle that you solve, I better see a picture, I better see setup, and I better see answers that I can find. So you're going to circle them or you're going to box them so I don't have to dig through your messy work. Some of you are very organized with your work and some of you are not. Okay. So if you can highlight your answers in some way, did I say, make sure. No, you really don't. So I don't know why you think I'm looking at you. Okay. You don't have messy work. Okay? Some of you are really organized and it wouldn't be a problem. Some of you are not very organized and I need you to highlight your answers. Okay. Is that better? Okay. All right. So one more thing we need to talk about. Okay. And this is going to be very important for our projects next week. There are two area formulas that we're going to talk about. Sometimes one area equals 1/2 base times height isn't like super convenient. So like this guy right here, do we know the height of that triangle? No, we would like have to do work to find it. Sometimes that doesn't sound super awesome. Okay. So we have a couple formulas that mathematicians have created based on the patterns of 1/2 base times height. If we know side angle side, then we can find the area of a triangle, an oblique triangle, by taking 1/2 side times the sine of the angle in between. You can write all three formulas down, or you can just write one of them down and be able to apply it to the different side angle sides. Okay. Oh, I thought that was hilarious. Yeah. Doesn't help us short people. And it looked like people were getting a little bit hot in moments. Okay, so I'm going to talk through this again. When we know side, angle, side, so the angle has to be in between the two sides. When we know side, angle, side, then we can find the area of the triangle. Instead of doing 1/2 base times height, this is basically 1/2 base times height with like the height figured in for you using trigonometry. Okay, so 1/2 side times the sine of the angle in between. Okay, this is basically just calculating the height of our triangle for us. Okay, so we're gonna do one example. We're gonna find the area of this triangle where angle C is 102 degrees, side B is 52 meters, and side A is 90 meters. Now, I'm always going to draw a triangle. Rarely is my triangle going to be drawn to scale. I don't know exactly how big the triangle is. I accidentally drew an acute triangle and I totally have an obtuse angle. If that bothers you, redraw it. But I really just want a visual of where my sides and where my angles are. Okay. So do we know side, angle, side? Because we have two sides and the angle is in between our two sides. Okay. So what we're going to do is to find the area, we are going to take 1/2 times the two sides times the sine of the angle that is in between. Now, you have a really nice calculator. There is no need for you to press the equal sign more than one time. In your calculator, literally type in 1/2 times 90 times 52 times the sine of 102 degrees, just all at once. Or my decimal places, 87. Okay, and we are talking about area. So since my sides were labeled in meters, let's go ahead and label our area in square meters. That's a lot. Oh, well, when we have a side of 90 and our missing side is going to be the biggest side, right? It's across from the biggest angle. That's a pretty big triangle. Okay. All right, so your homework this evening, make sure your calculator is in degree mode. Make sure you are drawing pictures for every problem. I would, because tomorrow we're even gonna know not tomorrow, Friday we're gonna learn another area formula. And just because I give you two sides and an angle, you better make sure that that angle is in between. So it could happen, ladies and gentlemen, that I give you two sides and an angle, but the angle is not in between, and then we have to solve for it. Okay, we can only use this formula if the angle's in between. So if it's not, you have to do some work to get there.